Shop Talks. Shop Talks is a presentation of the Ink Kitchen, free online information. We have a YouTube channel, check it out, subscribe. I'm here with my compatriot here, Stan Banks from T-Shirt Side Hustle. Who's our sponsor, Stan?
We got Emerald, Hirsch, Los Angeles Apparel, and Stahl's Transfer Expresses.
All right. And we have with us here Bill Smith and Dave Makin from Saati. They've agreed to give their time up here and prepare. We're going to talk about common screen problems, and I think they have a little presentation to start. And Dave, I think, is going to give us a little advice on how to approach the whole idea of a problem.
That I plan on doing here. So when people, our subject here is common problems, you know, I just want to say there's never been the one right way to do it all the time, because people work with mistakes and they can make good things happen doing it the wrong way. What we want to teach you here today is a little bit about how to look at the basic fundamentals and get there easier than struggling through trying to get to where you want. If you can follow some of these basic fundamentals that we're going to talk about today, they should be able to help address the problems that people have to experience as they try to get to the end result that they want.
I just want to say Saati is we've always been we don't call it pre-press, we call it screen making, because when you say pre-press it sounds like it's a warm-up act. Really the important work is done in the screen room, because if you make a good screen, then the printing part is easy. All right, we're manufacturers of mesh, emulsion, reclaim products primarily, so we are all about the screen room and how to do things right.
You, after all, call it screen printing, right? All right.
It is the most important part of the process.
All right. I thought art was, but let's go.
So we're going to cover 6 major areas of not making mistakes, being mesh choice, mesh preparation, the proper emulsions to use, coating procedures, correct exposure, and post-exposure.
When we think about our mesh choice here, you think about your LPI or your DPI. What are you trying to reproduce? Are you going to do dots, halftones, edge definition? All that needs to become part of the consideration to be able to make the right screen, pick the right mesh that you need to print on to get the results that you're after. So when we start thinking about details, we're thinking about our halftones, okay? If we're going to run a 55 LPI screen, I like to keep it simple and times that by 4, all right? What mesh do we need to put this on? If it's got halftones in it, it's got to be at least a 230 mesh. 55 times 4 comes in at 220. 230 is a pretty common mesh, so that gives you some margin of error in there. The lower mesh counts typically are not meant for detail. They're meant for coverage, they're meant for athletic type stuff, solid printing. And then we think about what kind of meshes. We have thinner threads and thicker threads. The thinner threads, they allow for better ink flow. So think about what you want to get to in your desired result. If we're looking for a solid athletic print, you want to think about the thinner threads at the lower mesh counts. If we're looking for our halftones and our details, we're going to be thinking higher. But that's how we would go and determine what minimum mesh should we be printing our halftones on.
This is a good slide that shows whether it's a film positive, whether it's direct to screen, whether it's wax jet or inkjet, it doesn't matter. When you start with your film positive or your original, you got a 10% and an 80% dot. Then you go to the stencil, you look at it, you got yourself a good stencil. You got 10% and 80% dot. But when you go to print, it doesn't quite come out that way. You go down to a 5% dot, and you get dot gain at the upper end, and in the shadows of 95%. Why is that? It's because the mesh gets in the way. I got a question for you. Everybody uses different mesh counts. And when you call up and order a 305 mesh, do you just order a 305? If you look at every roll of mesh that comes in, and you don't see it if you get pre-stretched screens, there's 2 numbers. There's 305, which is the thread count per inch, and there's a dot, and then there's another number. That number is the thread diameter in microns. We make three different types of 305 mesh, a 305/31, a 305/34, and a 305/40. If you look at this diagram, you see that there's different mesh openings, and what that could lead to below, that shadow below is the print. So in every mesh count, we offer several different thread diameters. And it's important to know, and we have a chart here that shows how you can choose that properly. Thin threads give great detail, but they're not quite as strong.
They don't give you any detail when they pop.
Exactly. When screens pop, we say, don't worry, we'll read more. But we don't want your screens to pop.
Yeah, they want you to use thin threads. But if you don't have a laboratory, you got to think about it. Go ahead.
But typically, if you're a t-shirt printer, we generally accept the fact that if you're ordering a 305, you're probably going to use a 40 micron thread, because screens are, in a lot of shops, treated pretty rough, thrown around, leaned up against machines, and you don't want them popping everywhere. So the 40 diameter thread is a stronger thread because it's thicker. But again, it leads to, this doesn't work on the TV, but you know, if you look at the two images below, you can see there's much more mesh opening, allowing better ink flow on the left slide bottom than the right slide bottom, and that can lead to sawtoothing or loss of dot.
So as Bill mentioned there, when you order your mesh, do you just call them up and say, I need some 230s, I need 10 230s, I need 10 305s? It's pretty common, and if you're not stretching screens in-house, it's really important to ask for that additional micron. What is that thread diameter? If you can ask that, your distributor should know, and if they don't, they can find out. But it's really important for you to be able to control this variable because it will determine the outcome of your print.
What about mixing mesh, or how should I say, fabric sizes? So I've got a 6-color job, 3 of my screens are 305 31, and I got 2 of them that are 305 40.
All right, so the question is, what happens when you mix the thread diameters? So you got 305s that are maybe thick and thin in one job.
Great question. You can mix them. In fact, a thinner thread will make a better base coat if you're overprinting on white. Reason being, a thinner thread will put down less ink, but it'll give you better coverage. Because you're not printing tall, square stacks of ink through a very thick thread. You're printing flat, wide squares of ink, not quite as high, but much smoother. That's why thin thread makes for a much better underprint than thick threads. So you can mix, but make sure you know what you're using, because we have machines that we linearize, and we make your 4% dot a real 4% dot, and your 98% dot a real 98% dot. But if we linearize it on a 305/40, and you start printing through a 305/31, it's going to give you different results.
If I can add to that, it's a great question, because when you do mix, we talk about that thread diameter. Thicker thread diameters can hold higher tensions as well. So if you're going to mix and match the same mesh, you want to get them as close to the same tension as possible so that your registration will not be affected.
I certainly want to touch on that.
Yeah, he wants to touch on that tension. I was going to get at that too.
Right? Because recently, it just seems that we've gotten away from tension. And you know, I'm going to classes with you guys, Bay Lab, anywhere. No one's statics, no one's checking tension.
All right.
It was drilled into me that I needed to check my tension and match my screen.
This is near and dear to me. I'm going to answer this one. So I agree with you 100%. I go in shops, I talk to people, they're like, yeah, we don't need Newman roller frames anymore. Yeah, well, what are you doing? So you can't wait till your rigid frame breaks. Like, you have to check tension, and you have to have the balls to like rip it off when it's lost tension, and people don't want to do that. So you either need an expensive, maybe it's not expensive to you, but you either need an expensive screen stretcher and know how to use it, or you need to send it back. You can't just stop using retensionable frames as an answer. And I see a lot of people doing that. I think you're 100% right.
Now, I am on Sherlock panels, okay? But they got better tension than a static. I don't have to maintenance them like a roller Newman, and my tension seems to be trackable and stay within a reasonable range.
All right, so the question was, the comment was that you have Sherlocks and that works for you. I agree, we use Sherlocks as well. But you have to do something. I think you made an excellent point with that.
Yeah, and I'll just put out there, this isn't advertising, but if you go to SaatiExpress.com, we have all mesh charts that have recommendations on the recommended tensioning for each mesh count. And my suggestion would be, back when Newman roller frames first came out, it was all about get the highest tension you can get. We even made mesh for him that was much thicker than the 305/40 because he just wanted to go for higher tension. And we found that the thread just elongated, and you're better off just using the standard thread weaves and going in between the low and high recommended tensions. And in my shop would work better. I printed for 19 years before I got into this end. We found that go into that recommended tension level for each thread count, but try and pick one that's almost all equal, because then you get better results on multicolor.
Let's move this along.
Can I add one more thing to that? Because I do stress tensions being uniform, whether they be 110s, 156s, 230s, or 305s, as close to possible to each other as possible. But it's very easy every time to put a tension meter on your screen and write that tension on it so you can group it with the job. You can keep like tensions together and you'll have much more success in the screen printing.
And here's an example of the chart we do have online that you can get. And you see there's a lot of columns there, and they're not just there for wasted information. You've got your thread diameters, your mesh opening, your fabric thickness, overall fabric thickness. That's valuable when you're looking at emulsion over mesh, and we're going to get into that. Your percent open area, but the theoretical ink deposit, to me, is one of the most important columns because it gives you a theoretical ink deposit, and it's theoretical, but it's a cubic centimeter of ink deposited over a square meter. And you see that the different 305s, we have a 305/40 and a 305/31, there's a huge difference between almost twice as much ink gets deposited, okay, with the 31 as the 40, because of the thinner thread and the less mesh interference. And then the last column there is the tension recommendation. And you can see that if you're at 81, you can be at 24 newtons, and if you're at a 305, you can be at 24 newtons. So you can use that as a guide.
Not every static screen is capable of holding the same tension though. You see our recommendations there, but there are some aluminum frames that are thinner walled that if you stretched them up to that tension, when you cut it away, it's going to really bow in on you. So the aluminum will help dictate what your ultimate tension will be. So the better quality the aluminum frame, the better the tension you're going to hold.
All right, move along.
Okay, we're going to talk about mesh preparation. Everybody probably uses a degreaser. There's a difference between a degreaser and a mesh prep. And I'll just say that a degreaser just takes grease away. A lot of people use Dawn dishwashing liquid. Don't recommend it. But there's oils and everything used to weave the mesh during the weaving process, and you get fingerprints on your mesh. So you need to degrease it. But this is a picture of a mesh with just being degreased. Okay, it's not giving you all the benefits of a mesh prep. And the other thing we want to stress is don't use fans in your screen.
Isn't mesh prep expensive?
No, it's not expensive.
Leading question.
If I can address that, when you finish reclaiming or degreasing your screens and you put fans on them to dry them, if there's no type of a filtration to your fan, you're blowing dust onto that wet mesh. That'll dry on there so that when you low coat it and you hold your screen up and you look, you will see every one of those little dust specks. They will ultimately start to affect your print. the durability of your stencil on the press and when it's going to break down and what kind of pinholes you're going to experience. So if you can do something different, rather put them on a rack at an angle and let gravity work with you, keep them in a room where they'll dry faster, just if putting a fan on them really causes a lot of problems.
Now, Rick asked about the expense of a mesh prep versus something else, dishwashing liquid. The cost of a pinhole while on press, how much does that cost you? You have to stop the press. You've got a loader and an unloader and somebody at the end of the belt. You got 7 screens that have pinholes on them that have to be shot out, and you've got to get under the screen and tape it and lose about 5 minutes. That's about the cost of 5 gallons of degreaser. So why wouldn't you use a mesh prep? If you avoid one pinhole, it pays for a gallon.
Penny wise, pound foolish. Go on.
So this next slide is a properly prepped mesh on virgin mesh. Now you don't need an abrader. You see, our mesh prep has, and so does other manufacturers. Autotype, I think, makes one that has the micro abrader. It has 4 important qualities. It's got a micro abrader that scuffs the mesh up. It doesn't tear it up, it scuffs it up. It's on a 3-roll mill, and it microscopically etches the mesh to give it more surface area for the emulsion to adhere to. Secondly, it's got a degreaser in it, which takes away degreaser. It takes away grease. Thirdly, it has an element in it that changes the surface level, the surface tension or the dyeing level of the mesh. And I always explain to people like this. If your emulsion is 40% solids, that means it's 60% water. Mesh is made out of polyester, which is plastic. Water does not stick to plastic. Plastic repels water. Almost like your hood when you wax it and it rains, you see a lot of water beads because it's pushing the water away. It does not want to adhere to the surface. The mesh prep has a wetting agent in it that allows the emulsion to coat and want to stick to the mesh. And the 4th element we have in it is a dye. And the dye is in there because we want to make sure you evacuate it with the weight of water with a hose rinse and make sure all of it's gone. Because if you leave some of this chemical behind, it interferes with the stencil.
So you blast it off, right?
No. You do not use a pressure washer to remove mesh prep. You use a hose, hopefully with no fitting on the end, just water flow from the top to the bottom of the screen and let it pull all of the product out.
See, you knew there was no dumb questions, but there's also dumb comments. There's no dumb comments.
There's no dumb questions, just dumb people asking questions, right?
That would be a common mistake, though. You know, people always high pressure wash off their degreaser. Well, they need to think of this as beyond a degreaser. It is a mesh prep. You want it to stay on the mesh, but you want a good rinse out of it.
I was going to call this every good question that you see on Facebook that has a dumb answer. That was what I was going to call it, because when I'm looking at Facebook, I cannot believe the case that some people...
On Facebook.
Yeah, so that's why we're here. Go ahead.
So we also make one without the micro abrader. There's an argument out there. People say they're showing pictures of mesh all torn up. That's people that use Comet. Okay, don't use Comet on your screens. It's got to be a micro abrader that scuffs the mesh, does not tear it up. And we make one without the micro abrader because once you do this to your virgin fabric, you don't have to do it again. Yes.
Scrubby brush with blue pad or brush with bristles?
All right, the question is brush with bristles or a scrubby pad?
We prefer the scrubby pad with the blue bristles, but it is the heat applied. It's the heat adhered, not the glue, because the ones with the glue, the chemicals eat at it and it falls off. Yeah.
Oh, that was worth coming right there. All right.
Mesh preparation. Go ahead, Dave.
This is an example that we took where we took on the same screen, we did half the screen with a degreaser and half the screen with a mesh prep, and then we underexposed it on purpose. So if you're looking at the one on the left, that is treated with a mesh prep. Underexposed, it held on to all the emulsion, all the detail, even though we're underexposed, and that's a common practice or mistake that people will do is underexposed to get your details, okay? If we throw this mesh prep into the process, you can get a better, proper exposure and hold all the details that you want without having to risk or sacrifice your stencil's thickness with underexposure. On the right was just well degreased, so this screen was shot at the same time, both of these rinsed out at the same time. You can physically see what a mesh prep will do versus just a degreaser here.
You know, this kind of fits with, in general, you want to give yourself the widest latitude of success, because, I mean, the bulb might be getting weak, or all kinds of things can be going on sometimes. Your films aren't perfect, etc. So the more latitude you give yourself, the better, right? You don't want to have to perfectly do everything, because you're not going to, at least not my employees. All right.
Okay. Proper emulsion, everybody knows there's lots of emulsions out there. You want to choose the correct emulsion for the type of printing you're doing, okay? Are you doing plastisol, water-based, solvent, UV inks? There's the, hot melt inks, conductive inks. There's a lot of inks out there. Now, most of us are water-based or discharge or plastisol. So there's a select amount of emulsions that you want to choose from. But you want a solids content between 35 and 50%. Okay, any less than that, emulsion, the cost of emulsion is the solids in it, not the water. So if you're buying a really cheap emulsion, you're probably not getting a lot of solids. So when the water evaporates off, there's not much stencil left.
Saving money on emulsion, that's a really good idea, right? It's like most expensive thing in the shop, right?
It's a factor, but you want to pick the right emulsion because it's going to save you money in the long run.
I'm opinionated. I'll just say it's dumb. That's not the place in your shop to save money, emulsion. Anyway.
You're going to hear the term here, emulsion over mesh. EOM is what we'll refer to it pretty much hereafter. Basically, as you look at the solids content in your emulsion, and a lot of the newer pure photopolymer emulsions have higher solids contents to them, all right? We're looking anywhere from 40 to 50% now. So the higher the solids, the less passes you need to build a proper EOM. Or perhaps you're looking into some of the HD printing. If you have a higher solids emulsion, you'd be able to build that stencil thickness, like going, instead of a 13 micron stencil thickness, you might be heading for like 100 or 200 or 400 micron stencil thickness. So understanding what the EOM is, emulsion over mesh, that's the overall thickness measurement of the dried emulsion that's been developed already. That's your best and most accurate reading after you've developed it. So we basically take that overall thickness, measure our mesh, find out what that thickness is, subtract the two, the difference is in microns. Now you take those microns, divide those by that overall thickness, and you have an EOM. We want to see between 10 and 20%. There are people who like to print thinner, okay? We understand that, and they have success with it, but what do they do to get there? We're going to help you understand a little bit about why that 10 to 20% is so important, especially with some of our new emulsions here. Go ahead.
And how do you measure EOM? There's a thickness gauge that you can get. You can get a cheap one, you can get an expensive one, but I will say the cheapest one is your fingertips. If you go in and you should be able to fill your stencil on every screen. If you close your eyes and run it across the substrate side of the stencil and don't fill your stencil, it's not thick enough.
Another cheap way is to have you come in and measure it for us.
Yeah, all of our reps carry gauge, all the tech tools to measure thickness and tension and everything else. RZ.
All right.
So the emulsion types we have, go ahead.
So back in the day, original emulsions were pretty much diazo emulsions. These were slow emulsions. They were great for water-based type inks. They were difficult to reclaim, not so much common now, though we do still see some around. Then we progressed into the dual cures, so you had kind of some diazo to it, and you had some photopolymer to it. It gave you a faster exposure time. It had a lot more latitude that you'd be able to print on a variety of different types of inks, whether they be UV, solvent-based plastisols. Then photopolymers come along. Now, dual cures, they like to stick to everything. Photopolymers, as Bill was talking about earlier, they don't like to stick to plastic. So we do things to the mesh to make them stick. Once you got them sticking and they're the right emulsion for the ink series that you want to print, like if you ever try and print a water base and your screen just falls apart, is that the right emulsion? You know, some people might say yes, but let me throw a hardener on there, and then it is the right emulsion, right? Because it ain't coming out. So
Right emulsion, because you got to cut the mesh out and
you got to cut it out later. We like that again. We'll read more. So, and then we move into today what we're seeing pretty common out there with all the new technologies, the photopolymer hybrids. It's almost to the point that one emulsion can work for a variety of ink series, you know, so where you might have 6 emulsions for the varieties that you do, we can get you down to 1 or 2. So the technology of these emulsions have really come a long ways. The solids contents are up there, the speeds are there, the pot life on them, there is no pot life because you're not mixing a diazo into it most of the time.
Pot life is once you mixed it or open it, how long it lasts, right?
Correct.
Correct.
All right, and then some are geared towards certain exposure units, right? Like, aren't there some new emulsions that like work better with an LED light, for example?
There are emulsions, most emulsions are sensitive in the 405 nanometer range. 405 nanometers is the wavelength of the light. They're good from anywhere from 285, which is more of a pure photopolymer, up to 420, which is, 385 up to 420, which is more of a photopolymer or diazo range. Now, most lights put out 405 nanometers. Trimetal halides put out 380, 405, and 420. Fluorescents are only in that upper end, and they're no good with certain emulsions. The emulsions don't even see it. So the LEDs can be tuned to a specific nanometer, and most of them are tuned to 405 nanometer, and all of these emulsions will expose at 405 nanometers.
I think today, what he mentioned earlier is kind of like some of the fundamentals of screen print as things have gotten a lot more accessible have gone away. So there's a big debate right now on how important the darkroom is when it comes to exposing or causing issues when it's burning screens. And so what is the effect on that? Because there's a lot of people now who say you don't really need a darkroom. While you want to store your screens in a dark place, you don't necessarily have to worry about the light sensitive piece of it anymore because of the emulsions that are available, and they're not seeing any difference in their screens.
Well, the answer to that is it depends what your light is putting out, and all of the lights in this room are putting out 405 nanometers. We have a special set of glasses we put on, and we go into your screen room.
You look really cool in them, Brad.
Yeah, it is cool. And it will only show any wavelength that the emulsion is sensitive to. So we can check your darkroom with these glasses, and you can buy them too, and see if your room is safe. And all I can say about not needing a safe darkroom, it depends on the speed of your emulsion. If you're only having it out for 20 seconds before you throw in the exposure, that's fine. But if it's a really fast photopolymer and it's going to expose in a minute and you're going to leave it out for 5 minutes, it's going to haze over and you're not going to be able to rinse it out. So I said to a guy one time that this emulsion will see what your emulsion sees. And he says, "Oh, I didn't know my emulsion was sentient." I'm going to think very differently about it in the future. So
Can you just touch on when to stir and when not to stir and how to stir? Photopolymer.
All right, stirring. When do you
On a
stir?
pure photopolymer, typically they come ready to use and do not require being stirred. If you're going to add a diazo into it, which you can, it will sharpen up some of the details if you're looking for a little more latitude or a little more water resistance. When you stir it, you are stirring air into it, and you really should be using a wood stick or a stainless steel, not just a normal steel stick, because they can react and affect your emulsions. Once you stir them, we like to require at least 2 hours to debubble. You know, preferably I would leave them overnight so they could get all the bubbles out of it, because those bubbles are pinholes waiting to happen.
So if it sits for 30 days, give it a stir, let it sit for 2 hours.
Yep.
The question was, yeah, so if it's sitting for a while, let it sit for a couple hours after you stir it.
If you're going to stir it, yep.
Our emulsions are manufactured specifically to degas within an hour. They call that degassing. The bubbles come up and popping. If you talk to our chemist, he'll talk to you for 2 hours about how to make a bubble pop quicker. But most people say 24 hours.
All right, what do we got here?
Okay, coating procedure. If you have a coating with two edges, you probably have one with a sharp edge and one with a rounded edge. The rounded edge is 1 millimeter radius. The sharp edge is a 0.5 millimeter radius. For t-shirt printing, you should really never be using the sharp edge. The sharp edge is really just there for what we call face coating. Face coating is coating wet, letting the emulsion dry, and then recoating the substrate side to fill in the gullies that form when where the water evaporate. It's more for graphics, printing, printed circuit printing. We're printing on blotters, t-shirts. So you don't need to do it. You really should just have the proper coating sequence on a rounded edge squeegee, or a rounded edge coating.
If I can say something really fast, as we talk about common mistakes, that's one that not a lot of people understand about their coating troughs, all right? And I come across plenty of shops that will coat their screens with a sharp edge, and they still get a pretty decent result. But we do have some slides in here that will show you why you really should be building with a round edge versus a sharp edge.
There's a lot of things you can do, doesn't mean you should do them.
Exactly.
All right, keep going
Exactly.
here.
What's a coating sequence? Like I've been in shops. I just say, show me how you coat, and they take it and they coat we use squeegee side and substrate side. You can say squeegee side and t-shirt side. I don't care, but they'll coat the substrate side, and then they'll go to the squeegee side, then they'll go back to the substrate side, then they'll turn the screen sideways. It's ridiculous. Okay? In general, your coating sequence should be, you first coat the substrate side at least once, because we're using direct emulsion and we want to make sure we encapsulate the emulsion so we get a physical bond of the emulsion onto the screen. You always, always, always end on the squeegee side, because when you coat the squeegee side, you are pouring emulsion through the mesh to the opposite side of the screen. And we want the stencil to be between the screen and the t-shirt, not between the screen and the squeegee, because the squeegee will just wear away the stencil and cause pinholes.
That was the best explanation of that I have ever heard. I'm serious. All right, go on.
Coating speed. I tell people if they think they're coating too slow, then slow down, because everybody coats too fast. And when you coat fast, you're frothing up the emulsion and you're causing bubbles, and a bubble in the middle of a thread is a pinhole waiting to pop.
The fastest you should really be coating is about 6 inches per second. And that can work with almost every manufacturer's emulsion. So there are some people that just really whip through a lot of screens. They've got 300 that they got to get through today, and they're doing them by hand. They're going to hustle through them. You know, I'm going to go coat different than Bill. You know, and I'm going to coat different than most of you guys. So if I'm sick today, you know, and then somebody else is coating for me, the printers are going to notice a difference. So we're about repeatability and consistency, which, you know, as we were mentioning here, how do we get more consistent? Probably the most important piece of equipment in your screen room that you should look at first is an automatic screen coater. They are inexpensive, but they are consistent, and they give you the quality of the print that you want out at the press.
And they're the same even if they were drinking the night before, right?
Yep. Doesn't care if you're hungover or it calls out sick. You can attest to that. I mean,
I think we need a contest, like, you know how the loading contests, they're always stupid, but they have those, right? We have a coating contest, like, see who can coat the slowest, right?
Yeah.
You could do that right here on the floor. All right, sorry.
drying position, you should have a horizontal screen rack, and you always dry your screens squeegee side up, substrate side down. Let gravity pull that emulsion to where we need it to be. And your screen room conditions. A lot of people don't address, besides being light safe, besides being clean, your humidity is a bigger factor in how quick your screens will dry than a fan. Because if you have a room that's 80% humid and you have fans blowing on your screens and you're like, oh, they're drying in 10 minutes, well, guess what? They're not dry. They're 20% dry, because they're only going to dry to the ambient conditions of the room. So it's really important that you get your humidity level down in the 30s.
I would say get your humidity as close to the solids content of your emulsion as possible. Get that water evaporated out of it.
I never heard that one either. I like it. But 30 to 50, right? Roughly.
Under 50.
Right. But 10's no good either, right?
10's no good either.
Yeah.
And I challenge you to get to 10 anywhere, unless you're in the Sahara. What's the function of your stencil? Okay, it's got a lot. It's got a lot of functions, Dave.
First things first is your stencil is going to be the image that you want to reproduce on the press. So we need to think about all the factors we've talked about before. It needs to be resistant to abrasion. It's going to be taking a flood bar, it's going to be taking a squeegee, and it may be taking an aggressive ink series. Some of these water-based and discharge inks are just terror on some of these emulsions. So what do we got to do? We got to make it right so that it can hold up to that abrasion. Your stencil needs to have an edge definition. As we get talking about it, you look at this image, you can see that has a really nice gasket between the mesh and the t-shirt. That's going to contain your ink as it prints, and you're going to have some fantastic looking prints. So, and then again, we want it to last throughout the print run. So these are the factors that we try to get you to easier by following those basic fundamentals we're talking about.
Most importantly, think of your stencil as three-dimensional, not two-dimensional. It's not just height and width, it's got depth to it. And the depth, most importantly, causes that gasketing so the ink can go through the mesh and under the mesh to print where you think you can't print.
Okay, this is where we're talking about EOM again, emulsion over mesh. It's just a good visual aid. So as Bill talked about, we start our passes from the substrate side, we finish them from the squeegee side. We push our emulsion towards the t-shirt. So now you can see this allows the ink to be able to flow all the way through, especially when you're printing fine details where your EOM is probably the most important. When you have big open athletic, you know, it is going to be the mesh on the fabric, so then at that point your tension is probably going to do the most for you to make sure that you get a good shear of ink. But when we're looking at those details, you got to think about what your EOM needs to be.
EOM is most important with fine details, Dave said, not if you're printing block numbers. Out in the middle of a print, the ink laydown is going to be 100% determined by the mesh you choose, not the stencil thickness. Stencil thickness only comes into effect at the edge of the, if you're doing fine lines, halftones, and at the edge of the print image.
Part of it is just consistency, right? You want consistency in your shop, right? Because if your art department makes films in a certain way, does their separation a certain way, you don't make your screens the same way all the time, you'd be tearing your hair out or turning gray, right?
If you have the same mesh, you have the same automatic coater, the same emulsion, you know you're going to be consistent with that stencil.
Yeah, the screen printing, good screen printing is about eliminating variables.
And there are so many, we need to control the ones we can, right?
Right.
All right, go on.
RZ. We'll briefly touch on this. It's mostly important in graphics, printed circuit printing, medical printing, but RZ is the roughness of the stencil. Basically, your stencil thickness controls your RZ. And when I said the sharp edge squeegee, if you see all those little gullies that are caused by the mesh, the water evaporating off and the mesh shrinking, almost like a wet newspaper on a sewer grate. When it dries, it takes the shape of the sewer grate. Emulsion will do the same thing. The sharp edge of the squeegee is to fill in, after that emulsion is dried, just to fill in those gullies and make a much more glass-like substrate. We basically just want to be under 10 microns RZ. RZ is a standard deviation measurement it takes a stylus needle and drags it across the stencil. We carry these pieces of equipment around with us. They're expensive. You don't need to buy one. Just call your rep and he'll come in and measure it for you.
But basically, in layman's terms, or layperson's terms, you want a smooth surface, right? And all the different stuff's going on, it's trying to keep it from being smooth, and you're trying to make it smooth. Right?
Trying to make it smooth. Not 100% smooth. You need a little bit of air under there if you're printing on glass. Some of you might print trophy plates or things like that. If it's too smooth and you go to print halftones, you create a vacuum if it's too smooth, and when the screen lifts up, air comes in through the halftone area and splatters your dot, and it looks like you have dot gain when you really don't. It's really just, or it looks like static electricity, and it's not. It's just air trying to fill a vacuum.
All right.
This is a high RZ, over 10, which you can see it looks like that newspaper on a sewer grate, and that's the type of print you get. You get a lot of sawtoothing as a result of it. Whereas if you have a low RZ value, you get good gasket, the ink comes through the mesh, goes sideways, goes over to the edge of this gasket, and gives you a nice smooth edge.
It's like screen porn. Go on.
Again, this is kind of talking about the quality of the emulsion. The higher the solids, the lower the RZ. So you get better edge definition and print details.
So this is an old, probably most of you have lamps that are exposing, and a point light source lamp is still the best to have. People upgrade to LED and they have a wide area. It's almost like an old fluorescent where the light's coming from everywhere and they're closing up their lines and their dots. A point light source LED lamp is still awesome. So there's different things affecting that. It's the intensity of your lamp. You should be exposing with an exposure lamp like this. It should have a light integrator, and it measures light units, not time, because as the light gets older, the time needed to expose gets longer with conventional metal halide lamps. Your distance affects it. We always say the distance from the glass should be a diagonal measurement of the image area, maximum image area, and that's how far your lamp should be from the glass. This lamp is also set up incorrectly, as it is not in the center of the image area. It should be centered in the image area. Dave, you want to talk about mesh color a little bit?
So mesh color, this is a common question that we get all the time, because people are like, what's the difference between white mesh and yellow mesh? Okay, other than one is yellow and one is white. Okay, white will...
You're going deeper.
White is it exposes very fast, but it also acts like a fiber optic thread. When light hits it, it carries it underneath where you don't want it to expose, and it will start to expose. So we get what we call undercutting. You make a dot this big, go that big, okay? So white will transmit light. Yellow likes to absorb light. So if you're after some high-end details, the yellow will just absorb it straight in and not transmit it like a white screen would do. Now, white mesh will expose about 30% faster than yellow mesh, and it has a place in the market. But when details are involved, you will get much better details if you look at doing yellow mesh.
And like Scott's question before, you got to gear to one or the other, right? Like you can't have exposure times for your white and then expect the yellow one's going to be the same.
It's going to touch on that. Usually your lower mesh counts are white because it takes a lot longer to expose a low mesh count because you have more emulsion on there and more mesh to go through. But typically we're not doing fine detail on low mesh counts. So I would say if you're under 125 mesh, go white. You get up to the 140s, switch to a dyed mesh. Okay, this way you get the light polarization, and the yellow mesh or orange mesh, it just exposes the same. It polarizes the light and doesn't let it fly up the thread and undercut.
You know, some people don't have time to think about all this that much. Some of those rough guidelines I think are pretty good. You know, if you're doing over a 110, use dyed mesh.
Yep.
You're not going to go wrong with that. That's
people
for sure.
use white because they want to save money. I mean, a yard of dyed mesh is not even $1 more than white mesh, and you're going to get how many thousands of prints out of it? You're chasing fractions of a penny. It's not worth it.
As you continue to think about your exposure time, we have a couple more factors on there, your coating thickness. If we make a really thick stencil, you know it's going to take longer to expose. Your emulsion, if it was a dual cure emulsion, it's going to be probably 8 times longer to expose than some of these new hybrid emulsions. So considering your light source, your distance, your EOM, your mesh color, and then what type of emulsion you're using, these are all factors to consider. You just can't go from one emulsion to another emulsion and do everything like you've done before and expect the same results. There are emulsions that have more latitude, which means you can screw it up, okay? A big window of opportunity to underexpose or overexpose and still get a pretty good screen. But there are some of these newer hybrid emulsions that window closes, so you need all your ducks in a row so that you will get what you want.
For someone who's just starting out without all the fancy tools to kind of figure this stuff out, how do they go about knowing if they're underexposed or overexposed without any of the fancy tools to do so?
If you came to our booth, we give them away. We sell them we have what's called a 21-step wedge. You don't need to waste a screen like the old exposure calculators to figure out exactly where you should be. The old exposure calculators would put you in the ballpark. This one puts you in your seat. If you get you're using film, if you get a hard 7 with a pressure washer rinsing out the image, if you get 7 and below, has emulsion on it, you're perfect. If you're direct to screen, we want 6 or 5 and below.
Actually, I mean, you actually helped. My son had never shot a screen, and he was able to use that and get a proper exposure. It's not that hard. He had never, ever shot a screen.
We pretty much, if somebody asks us and they're a new emulsion customer, we'll just send this with the emulsion.
Now let's say you don't have one of these, or you don't have any kind of an exposure calculator. What can you do now? When you go back home, if you image a screen, from the substrate side is getting the light all the time. So it's going to feel nice and wet, just water wet. Then if you felt the squeegee side of the screen and it felt kind of slimy, like fish scale slimy, that's a telltale sign that you're underexposed already, okay? So you really want the front and the back to feel the same. That gets you close. We want it right, because if you have an underexposed screen, you're going to have a really hard time in reclaim, especially. Your screens may not hold up for your whole production run. If they do and you go back and you reclaim, it's going to take you probably 10-15 minutes to reclaim a screen instead of 2 or 3 minutes.
An underexposed screen could lock up, especially if you use screen opener. But a fully exposed screen will hold up and reclaim actually easier. And another problem we see a lot is you get this clear film in your image area and you get the spot cleaning gun to shoot it out because you don't know where it came from. That's from underexposure and emulsion running into the image area and drying. Onward. Yeah, we'll zip through these because I don't know how many we have left, and then we'll cover some questions. This is just a ideally exposed screen. You'll see that it's exposed the same on throughout the screen. The color dark blue indicates exposure, and it's a little tough to achieve that with a point light source. This is your typical exposure, uneven light intensity. Edges of the screen are underexposed as opposed to the center. Wide exposure latitude is even more important. Now with direct to screen, both lasers, wax, and inkjets, this is less of a factor, because you can overexpose it and still rinse out your image area very nicely. There's the exposure calculator we talked about. It's not like the old ones that depend on color change, because the only emulsions that color change when they're exposed are those with diazo in them. Pure photopolymers do not change color when they expose.
So notice to the right, you know, if you're using one of these and you're using film or even some of the direct-to-screens, we want to see a solid 7 stay on the screen. Everything else is going to wash out. These are just filters, okay? So if we came in at, say, a solid 10, we are 3 blocks overexposed. You can look at the back of this little chart and it'll tell you what your exposure time that you imaged with to multiply or divide with to get you down to a solid 7. So again, this is not to get you close, this is to get you right on.
This is just an example of a very high resolution. It's got dyed mesh, great vacuum, 16 inches HG, which is mercury, which is a measurement of vacuum. You need at least 16 on your gauge. Point light source for best film exposures, that's film. And DTS and LTS give you the best image quality, next to an image setter, which they're not making anymore. With the new hybrids emulsions, we just want to mention, if you post-expose them, you get definite water resistance. Everything is plastisol resist and UV resist. You cannot post-expose. You can leave them out in the sun all day long, and you can't. The more you expose them, the better they'll reclaim. So you can underexpose these new hybrid emulsions, get the detail you're looking for, and then post-expose it forever, and you can run discharge, water-based, plastisol, so you can truly have one emulsion for all applications. There you go. I didn't know if there were more slides or what. That was close to an hour.
All right.
Any questions?
Yeah.
Can you guys talk about thin thread mesh?
Thin thread. Dave.
Okay, so the thin threads are more delicate. You know, we say that up front. You cannot print a thin thread like you can a standard thread. Thin threads typically hold a very nice tension. They have more open area. They have better coverage and actually use less ink. Somebody had once earlier asked, you know, can you use a thin thread with a dye blocker print? You know, if we're going to get better ink coverage, absolutely. Thin threads have kind of become the standard almost for people that are doing underbases, where you're really trying to get good coverage doing a print flash go rather than a print flash print. You know, you can see some examples that we have where you can do one with a standard thread and one with a thin thread, but understand they are more delicate. Okay, they definitely are an advantage when you're trying to print your details and your underbases.
Yeah, more ink down does not necessarily mean better opacity, and we prove that with our thick thread and our thin thread. We have 30% more ink with the thick thread because it sits taller and puts more ink deposit on. 30% less with the thin thread, but it's spread out and gives you better coverage, and it actually looks like there's more ink, but there's 30% less ink. So inks are expensive. It also saves on ink.
When you think about your thin threads also, you might change how you print off contact specifically. So the thicker threads, typically, you know, if you can hold a higher tension, you lower your off contact, you get better registration. But you're not going to print a thin thread and a thick thread at the same high off contact because of that delicate thread.
Depends on your housekeeping and who you have working for you, though. Also, you're not going to print anything if they're ripping all the time. So they do need more care, and they're not for everybody. I just want to say that.
Absolutely.
Any more questions?
All right, well,
I'm a Quaker.
I know.
Other questions?
I guess not.
If anybody is interested in a 21-step guide, you can come by, and if we don't have any more at the booth, we can send you one. So please feel free to come by and visit us over at Saati, number 641.
How about a hand for Dave Makin and Bill Smith here? They'll stick around, or they'll be in their booth over there if you have more questions later. Thanks for coming. Check out our YouTube channel. This will be up eventually.